we're gonna do division today. So if I have the same variable, right? It's called the base. So if I have the same variable, I won't ever ask you to define it, but sometimes I'll use that term base. Then I can subtract exponents. Okay, let me also be clear. We have not talked about negative exponents yet. I think that's Monday. But I want when you guys do the subtraction, I want you to always have positive exponents. Okay, so like here, I'm going to move my k squared, right, up and go k to the 12 minus 2, which is k to the 10th. I would not move my 12 down. So when which one did I want to do? Here, right, I reduce my 4 and 8 and I get 1/2. And then I go n to the 5 minus 1. So I'm bringing the exponent of my denominator and I'm bringing it up. Aiden, I don't want your ears covered. Thank you. I know it's Danny's fault. No, I'm just kidding. You just couldn't resist because they were, I know. All right, questions that you guys have? I'm going to do subtraction. I can do another one. What happens when I got like multiplication and division? Oh no, right? What? No, I'm doing 13. I'm 14. So I'm going to distribute my multiplication first. I'm going to do the multiplication before I do my division. So I get 2 to the 3rd, a to the 2 times 3, b to the 4 times 3, divided by 4a cubed b to the 7th. So I get 8a to the 6th, b to the 12th, 4a cubed b to the 7th. I will pause for a second because I know I'm going fast. It's hard. You can't see it? Oh, it's on the eraser? Stupid eraser. Alright. No singing in class. You know better. No. Okay. So I reduce. So I get 2, a to the 6 minus 3, b to the 12 minus 7. So I'm subtracting my exponents. So I get 2, a cubed b to the 5th. It's only a one-sided assignment today, but I'm still not going to make you do all of them. Well, here's the thing about this. The thing is that when I look at this, it's like, don't get me wrong. What are you doing? You break the desk, you owe me $600. Okay. Stop.
It's okay. I get confused.
Okay. The thing about your homework assignments is that if you want more practice because you need more practice, then do more problems, right? But if you don't need the practice, like I need you to show me that you're going to do like one of each kind, right? Do I need you to do 8 of each kind? No. So, yes.
So like if each desk is $600, how much
That has nothing to do with the lesson that we're doing right now. Okay. So again, I'm going to do my multiplication first. I'm going to combine what's in my numerator before I divide. So I'm looking at 23. I'm going to take my squared and I'm going to distribute that to both terms. So I get 2 squared x to the 3 times 2. Then I'm going to distribute my cubed to both terms. So I get 3 cubed y to the 4 times 3 because I'm using my multiplication rule. Right, that we did yesterday. And I still have my 12x to the 4th, y to the 5th in the bottom. So I'm going to combine. So I get 4 x to the 6th times 27 y to the 12th divided by 12 x to the 4th y to the 5th. Now, I know a couple days ago, some of you guys were asking me this question, right? Oh my gosh, well actually you were complaining. Oh my gosh, I have to take 4 times 27 and multiply it together before I can divide by 12. The answer to that actually is no. I don't have to do that. I don't have to make my life harder in order to simplify it. Okay, what I do know is that what's 12? 12 is 4 times 3, right? So 12, if that's 4 times 3, I can get rid of my 4 first. And then what do I know about 3 and 27? 3 goes into 27 evenly. So I can then reduce my 3 with 27 and get 9. So I don't actually have to multiply them together to then reduce. I can leave it like that, leave it a mess, and now my answer is really easy. Yes?
Could you reduce if the numbers were on the same side of the equation?
What do you mean?
Like, if, like, say there's 2 numbers at the top with the same multiples, and then you reduce them if they're on the same side?
Yes. So I can do this with any fractions like this. I don't have to multiply them first. Now, you're using a calculator, so it's not terrible, but I'm showing you this. Why? Because in IM2 next year, you're not getting a calculator.
I don't like this.
Half of the math classes you will take, you will be allowed a calculator for. But it's dependent upon what advanced placement class allows. So, for example, AP Stats, calculator all the time. AP Calc, calculator like a quarter of the time. So we have to prep you guys for both classes. So we start off with a calculator in IM1 and then we remove it in IM2. And we remove it in IM2 because you don't actually need it as much. We teach you guys how to do some of the arithmetic. We relearn some of our fraction stuff. And then because we start off with geometry, there's not a lot of arithmetic, heavy arithmetic involved. Okay. All right, so back to this. So I get 9x to the 6th, y to the 12th, divided by x to the 4th, y to the 5th. And now I can do my subtraction of exponents. So 9 x to the 6 minus 4, y to the 12 minus 5. So I get 9x squared, y to the 7th. Now, I will also tell you guys something, because I graded your guys' tests yesterday. If I cannot read it, I cannot grade it. Some of you with your pictures in GradeScope, they're blurry. If I cannot read it, I will not grade it from this point forward. And if I don't see work and all I see is an answer, I'm not giving you any credit at all. And I've told some of you guys quite a bit about writing stuff out, making sure that I can read it, making sure that I see all your steps, right? But if I just see answers without work, I'm not giving you guys credit. Yes, Aiden?
What if it's simple enough and the thing written out is the work that I need to do, and that's it? I just have the answer the next step.
The issue that I have is that on the test, people did this, probably on their calculator, and showed nothing. So when I have on my rubric that I give you 1 point for plugging in 4, and I don't see that you plugged in 4, you don't get credit. Because here's the thing, with one form for the entire class, I have no idea whether or not you looked at somebody else's paper and just copied down the answers. And in a lot of ways, if I didn't give you guys a calculator, you'd have no choice but to show some steps, right? I will tell you that I know what I think is work should be shown. And if I think you should have shown a step, I won't give you credit. Okay. You could always ask me though. You could always ask me to look at your homework and I will tell you whether or not I think that that's okay or not. And there's some of them I think you're right that you can do in your head, and that's fine. I will tell you that when you get to advanced math with Mrs. Roach or IM3 with Mrs. Roach, you will have to show every single step, regardless of whether or not you can do it in your head or not. Because that is what she requires for everything. I'm a little bit more lenient. I make you guys show work for a few reasons, mainly because College Board requires it, some steps for certain problems. And there's a lot of stuff that you can skip once you get to calculus. But there's some bare minimum stuff that you have to do. There's no race to finishing your test first if I can't see steps or understand what you did. Which I'm fighting that with the calculus students right now. I won't grade their stuff. It's like all over the place. I have no idea where the right answer is. And if College Board just won't do it. When you get to an AP level math class, we're not the ones that grade it. The AP test. Somebody else does. Somebody that doesn't know our school. Somebody that doesn't know you. They don't even know your name when they see your paper. They are not getting paid enough money to figure out what your steps are. That stipend is not enough for giving up their summer to read it. Okay, so, but you could always check with me and I will tell you. Because yes, there is some stuff that I think you guys can do in your head and that's fine. For example, like this, right? Like I'm showing like the little arrows. I don't expect you guys to show me the arrows. I'm doing it because if you blink, right, and you look down for a second, you're not going to know what I did. Okay. So when I do this last one, I liked this one because it requires more effort. So I wanted to show you guys one that was a little bit harder, just so you guys don't get confused. Again, all these rules of exponent things work when... It's like when you like add fractions, right, with with this common denominator, and then people accidentally add the denominators together. It's kind of the same thing. Like, when do I use my rules of exponents and when do I don't? Okay, I don't use rules of exponents and I combine like terms when I get to the point where I have addition or subtraction. The minute I have addition or subtraction, it's combined like terms. Once I get down to that point. I'm not there yet. I have to simplify that left term first before I can go through and look to see if I can combine like terms. So I have a negative 6 squared, and I know somebody asked me yesterday about negative 1 squared, right? There's a big difference in your calculator by going negative 1 squared or negative 1 squared. If you put in negative 1 squared like the left, it will give you negative 1. Why does it do that? PEMDAS. It does the squared first of 1 and then multiplies by a negative. If you take the negative 1 and it's a quantity square and you put parentheses around it, it will give you a positive 1. It's because your calculator thinks it's smarter than you and it's not. And it does order of operations the way you don't want it to. Trust me, like, you could ask any calculus student right now, they are super frustrated with their calculators. I had probably about 20 students yesterday out of 85 that reset their factory reset their calculator yesterday because they couldn't get it to work. They just turned the calculator over and pushed the button, but okay, so that I know that question came up somewhere over here in the last couple days. So I want to make sure that we answer that. Here I get x to the 4th time, and I'm multiplying that. Yeah, okay. And then I get y to the 6 times 2. And then I have a negative 3, and that's a quantity squared, and x to the 3 times 2, and a y to the 5 times 2. And then my little negative 7x squared, y squared just comes down and tags along for fun because there's nothing I can do with it yet. Questions that you guys have? I gotta simplify this left-hand side, so a negative 6 squared is a 36. I get x to the 8th, y to the 12th. I get a 9x to the 6th, y to the 10th. I can reduce my 9 with my 36, so I can get 4. I get x to the 8 minus 6, y to the 12 minus 10, minus 7x squared, y squared. So I get 4x squared, y squared, minus 7x squared, y squared. So I get a total of negative 3x squared, y squared. Okay, back to Aiden's question. I would have expected, as far as work is concerned, I would have expected to see that step, and a final answer. Because, like, the multiplication, right, I think you can do in your head. Or at least if you didn't do the multiplication right in your head and you accidentally did, instead of doing 6 squared, you did 6 times 2 and got 12. At least I would know, right, with seeing that middle step, what you did wrong. So I can at least give you credit for doing something right. Okay. Questions that you guys have?